Hi, my name is Jack and this is Lab 4. In this week's lab, we take a look at some up-down action. Don't worry, it's not a fraternity mixer. We're going to take a look at a mass on a spring that is moving up, down, right, and left, and then we will try and model the motion of the spring mass system using some of the fundamentals of physics. First, let's take a look at the formulas we'll be using. Obviously, we'll be using Newton's second law and the energy principle. Here you can see both formulas on the screen. Alright, let's take a look at the code used to create the model. In order to create the model, we take the spring constant K from the video where the spring only moves in the vertical direction. Through some calculation using Newton's second law, we can obtain a mass of 0.402 kilograms and a spring constant of 6.83 and an initial length of 0.123 meters and a final length of 0.7 meters exactly. I also created a CSV file of the data from tracker using Excel, and I also found the period to be 1.52 seconds in the Y direction and 1.61 seconds in the X direction using the video data as it was the easiest to use. As you can see here, I put all the necessary formulas and variables that serve as the fundamental equations to give us our model. This includes the potential energy of the spring, the potential energy due to the effect of gravity, and the kinetic energy of the spring mass system. The net force is equal to the force of gravity on the mass plus the force the spring exerts on the mass. All the while, the force is acting in the direction of L hat, which points in the direction of the connection to the wall. L hat is constantly changing, and that is why I put it in the way I did. This way, we can compensate for the change in length and the resulting change in force. I then edited the code to graph everything to give us this model. Here you can see the code run, and here you can see the motion of the model is fairly spot on to that of the real video. Also note that the traced blue line aligns very closely to the path of the mass in the video we were provided with. Now for the questions. Question 1 asks whether or not the energy principle is satisfied. Since all the energies add up as seen in the graph, the energy principle is satisfied. Question 2 asks to compare the oscillation time in the y direction and the x direction. Here are my results as previously mentioned. The spring's motion is elliptical, which gives it a slightly longer way to travel in the x direction. Therefore, it takes longer than in the y direction, approximately 0.09 seconds longer. Thanks for watching my video, and I hope you tune in 2 weeks when we do some other crazy lab.